Okay, in this video I would like to tell you about interactive simulation in SAMSON. So to do this I'm going to load a nanotube model here, and I'm going to apply a simulator to it by going to the simulation menu and select add simulator. So in SAMSON I can add a simulator to a group of atoms. For example, I could select these atoms and apply the simulation only to this part, or select everything, or select nothing and apply a simulator, because SAMSON will ask me whether I would like to apply a simulator to all atoms in the document, since I have no atoms in the selection. So I say OK, and now I can choose a name for my simulator. So I'm keeping simulator 1. I can choose the force field, and by default I have only the Brenner force field, but I can add more from SAMSON Connect. And I select the state updater. So a state updater in SAMSON means the algorithm that's going to be used to move the simulation by one step, to advance the simulation by one step. So this could be a minimizer, for example, steepest descent algorithm, or this interactive modeling updater that's particularly appropriate for interactive modeling applications, or regular dynamic simulation algorithms like partition Euler method or velocity Verlet, or adaptive integrators. Okay, but I'm going to do just minimization for now, so I select OK, and I can see that two things happened. The first thing is I have now more nodes in my document. I now have a dynamical model with a green icon, which is used to represent degrees of freedom in a nanosystem. So a particle system is a dynamical model in which I have particles. So precisely here I have one dynamical particle associated to each structural particle, meaning 3 Cartesian degrees of freedom associated to each atom in my structural model. And associated to this dynamical model I have an interaction model, the Brenner force field that's appropriate for hydrocarbon systems, with a red icon. And I have a simulator here which points to this dynamical model, this interaction model, and the state updater. That's the first thing that happened, these new nodes in the document. And SAMSON also displayed the properties of this interaction model and the state updater. So the property window of the interaction model just shows the Brenner energy in this case, minus 2000 electron volts. And the property window of the state updater, the interactive modeling updater, shows both the time step size and the number of sub-steps per time step. So thanks to this I have locked these windows here to keep them always on top by clicking here. I can now start the interactive simulation by going to the simulation menu and say start simulation, or press space, and that's very convenient to start and stop frequently with the space bar, the simulation, or use this icon in the simulation toolbar here, play, pause, play, stop. Okay, so I'm going to start the simulation here, start the simulation, and I can see that the nanotube is being minimized, the energy has been reduced a bit. And I'm going to use an editor here, the displacer editor, to move atoms. So remember, I double click on this atom with shift pressed to center the camera on this atom. And now what I can do, if I just, without shift, if if I just click on the atom, I can move this atom using the displacer editor, but since this nanotube is being minimized at the same time, the neighboring atoms are moved as well. Okay, so because the Brenner interaction model is a reactive force field, I can actually break bonds if I pull strong enough. So that's what I'm gonna do here. I pull strong enough, and I have replaced this cycle with 6 atoms by a cycle with 5 atoms, and I'm going to do this all around the boundary of the nanotube. And you can see that because the structure is being minimized, the nanotube here has a curvature, and so I can use this to continue making these modifications, these topological modifications here, and the minimization helps me determine the structure that the nanotube would happen if it had this topology. So I'm continue making these modifications. If I pull too fast, I'm going to break, so I'm going to do it slowly. Here, I'm going to try to do the same thing here. Okay, and then I'm going to pull it here. Okay, and finish it here to complete my model. Okay, so I leave it minimized and I reach a lower energy. Okay, so one little trick with the displacer editor: if I have more than one atom that are selected, and when I select the displacer editor, I click on one of the selected atoms, then all the atoms are moved with the displacer. Okay, and of course I could also use other editors, for example the twister editor here, but we'll come back to that in a different video. But just a quick example, this editor allows me to add constraints. So I click on an atom and it lets me add constraint, and I can then move this constraint to do more global deformations while constraining the positions of some atoms. So you see that several things are acting at the same time. One, the fact that the nanotube is being minimized, and the fact that this twister editor is helping me apply constraints on the nanotube. If I switch back to this displacer editor, then these constraints are going to disappear, and the nanotube is going to go back to its original shape. And I can speed up this operation by increasing here the number of sub-steps per simulation step. Okay, and I go back to 1 to make it more interactive again. Okay, so that's it for simulation in SAMSON. Please don't hesitate to experiment with other force fields that you can add from SAMSON Connect, other state updaters as well. And thank you very much for watching, and I'll see you in the next video. Thank you.